All right, so let's start with a line segment. Determine the length of a line segment. All right, cool. So we're given 2 points. If the points are vertical or horizontal, it's pretty easy to say what the length is. Like for example, here, this one, A26. So we're somewhere here, 26, and B56. And this is our line segment that goes from A to B. What's the length of this line segment? So it goes, the y values are the same, right?
Mhm.
But the x values are different. So we just went 3 units to the right. So therefore, the answer to this is just 3 units. That's the length. For B, it's very similar, except now it's vertical. So we have -7 and 8. So this is -7 and 8. And down here we have -7 and -5. What's the distance between these points? How long is a line segment is the question. Is it 3 units?
No,
Because 8 minus 3 is 3. 8 minus 5 is 3. No, so what's the answer?
it's 13.
It's 13, yeah. So if it's horizontal or vertical, it's very simple. You just count the squares. But the third one, the third case here, it's not gonna be, I'm gonna steal their graph. They didn't even draw it. Okay, cool. So you're not always gonna get a horizontal or a vertical line. You will get a diagonal line, like we'll see in the next question. So that method, maybe counting boxes may not work as well. So we have -4, 2, 4, 6, 7. So this is our first point. That's P -4, 7. And then we have 3, 1. So this is Q 3, 1. Now the question is the same. The question is, what is this line segment? Now here, counting boxes doesn't work as well. So what you need to do with this one is you need to turn it into a triangle. Something like this. What's the height of this triangle?
6.
6. What's the base of this triangle?
7.
7. Is this a right angle triangle?
Yes.
Yes, because this line is coming straight vertically down. So now our length PQ is just going to be a Pythagoras theorem. 6 squared plus 7 squared, yeah?
Mm-hmm.
What is that? 50 plus 36, so 85. And that's it. Cool?
Mm-hmm.
So if you have a line segment that's diagonal, you can just turn it into a Pythagoras. Here, let me show you an alternative method of doing this, because you might not always want to sketch. You can use the distance formula, which says this. It's x2 minus x1 squared. It's basically Pythagoras theorem, but in like one step. Y2 minus y1 squared. Y2 minus y1 is the height. X2 minus x1 is the base. So when you do this, you can either label this one as x1, y1, or this one as x1, y1. The order doesn't matter because you're going to be squaring it anyways. But they must be 1, 1, and 2, 2s, like this. So let me plug that in. So x2 is 3 minus -4 squared plus 1 minus 7 squared. And you'll see that when we do this, we get 7 squared plus 6 squared, which is what we had there as well. So this is doing it the formula approach. This is doing it the geometry approach by sketching it. This one is probably going to be quicker, usually. And they will both give you the same answers, so it's not a super big deal. So again, the formula is just the difference in x values squared, and plus the difference in y values squared, and a huge square root because of the Pythagoras theorem. That's a nice little fall picture. So we're going to Toronto, to Carleton University in Ottawa. Sometimes he takes Highway 401. So we're at Toronto. We go to Prescott, and then we go from here to Ottawa. So he either goes this way, or he can just go directly from Toronto to Ottawa using Highway 7. On a map of southeastern Ontario, with the origin at Windsor. All right, this question is getting more complicated with every sentence. So in the center of the grid, we have the city of Windsor. That's the origin. And the coordinates in kilometers, Toronto is at T301, right? So we're just gonna have to kind of approximate. So let's say this is Toronto, 301.5 and 200. Prescott is at 580 and 450, so Prescott is somewhere over here. 580.5 and 401.5. And Ottawa is at 542 and 474. And Ottawa is up there somewhere. $542 and 474. Approximately how far does Winston drive using each route? So what's the question asking us? It's asking us for the line, this one, using the first route, right? Goes to P and then goes to O, so we need to find those two line segments, add them up, and then we also got to find this line segment from T to O and add it up. So I'm just gonna use the formula approach. Let's first kill the direct route. So he just goes from T to O. Remember, the formula is, again, it doesn't matter which one you do first. You can definitely do y2 minus y1 as well, because you're just adding them up, so the order doesn't matter. I'm gonna say this is 1, 1, this is 2, 2. So this will become 542 minus 301.5 squared plus 474 minus 200 squared, like that. It's about 500 kilometers, so let me see what this gives me. 542 minus 301.5 squared plus 474 minus 200 squared, the square root of that, I get 364.7 kilometers. So this is the distance of the direct route that goes from T to O. How do we find the distance of the other one? Of the indirect route when we go through the city of P.
First, you find the distance from T to P.
Yeah. So the second distance will be TP plus PO, right? Like this.
Mhm.
So this will be, again, the order doesn't matter. It's going to be 580.5 minus 301.5 squared plus 401.5 minus 200 squared. So that's the distance from TP. And then to this, we're going to add the distance from PO. So it'll be 542 minus 580.5 squared plus 474 minus 401.5 squared, like that. And let's plug this in. square root of that plus the square root of 542 minus 580.5 squared plus, which one are we expecting to get a bigger number? Which distance do you think will be more? The direct route or the indirect route?
The indirect route.
Yeah, so this indirect gives me 426 kilometers. So it's just slightly more, maybe half an hour more of a detour. And that's it for this question. That's just knowing how to use the distance formula, and it's a calculator plug and play from there. Here's a difficult question, which you kind of have to think about. In terms of difficulty, again, we'll just use the distance formula and the slope. The concept itself is not difficult, but the trick is difficult, I think. You kind of have to think about it. So we have a line 2x plus 3. So 1, 2, 3. And we go up 2 across 1. So this is our line 2x plus 3. And our point is 6, 5. So 2, 4, 6. 1, 2, 3, 4, 5. Actually, this is way easier. Alrighty. The question is, find the distance between these 2 points. Oh, sorry, the line and the point. What do you think we do? Is the answer, what if we just count this? Is this the answer? 1, 2, 3, 4, 5. 5 units. Will that do it?
No,
Why not?
because that's not like the only distance.
Right. So which distance would be the best to find? Let's find the shortest distance. The shortest distance is synonymous with 90 degrees, perpendicular, okay? It's also called a displacement. Shortest distance is called a displacement. I think that would be the best. So we need to find, again, I can't be super precise here, but we need to find this distance here. In other words, we need to find this point. We need to find this point where this angle is 90 degrees. Step 1, we find that point. And then once we find that point, we can use the distance formula or Pythagoras theorem to find the distance. So our first task is going to be find the point. So this is point A. Let's say this is point P. We need to find this point P such that these two lines are perpendicular. All right, so how do we find that point? If the slope of this is 2, what's going to be the slope of this line that's perpendicular to it?
-1/2.
Right, so we know this line PA, has an equation y equals -1/2x plus some value b. Can we find b? Which point do we plug in to find our y-intercept?
6, 5.
6, 5. So 5 is equals to -1/2 times 6 plus b. So 5 is equals to -3 plus b. And b is 8. Yeah? Therefore, this equation of PA is y equals -1/2x plus 8. So this is the equation for PA, this line. Now, how do we find this point, P? The hint is that that's where these two lines meet.
You set the 2 equations equal to each other?
Exactly. So next you're gonna find POI. So you just do y1 equals y2, or you do -1 over 2x plus 8 is equals to 2x plus 3, like that. And using quick maths, this is gonna be 2.5x equals 5. X is gonna be 2. I mean, we could have kind of deciphered it from the graph. X is 2, and to find the y value, we can plug it into either one of those equations. I'm gonna plug it here, so it's gonna be 2 times 2 plus 3. It's going to be 7. So that point is 2 comma 7. Since we already have a sketch, let's just turn this into a triangle. So this is our triangle. What's the height?
It's
gonna
2.
It's 2. What about the base? 4, right?
4.
So what's the hypotenuse? Is it 3? Because we have 2, 4, 3.
It's the square root of 20.
It's the square root of 20. And that's it. That's the answer to this question. Well, a little bit difficult because you have to actually find the point first. And to find the point, you need to know that when it comes to distance, shortest distance is the best. And shortest distance is synonymous with perpendicular. Yeah, with 90 degrees, perpendicular. Let me show you how you can rewrite root 20. So right now this is a radical. We want to write it as a mixed radical. To write it as a mixed radical, you should always try and fit the largest square number you can within the radical. What are square numbers? It's like 4, 9, 16, 2 squared, 3 squared, 4 squared, like that. What's the biggest square number we can fit that 20 is divisible by? These are your square numbers. 2 squared is 4, 3 squared, like that.
16.
As in, like, it needs to be divisible. 20 needs to be divisible by that.
4.
4. So we're going to rewrite this as 4 times what? 5, right?
Mm-hmm.
And then we split this apart. It becomes root 4, root 5. So this becomes 2 root 5. So that would be the final answer. Usually we write a radical as a mixed radical, if you can reduce it. Cool? Let's remember distance is perpendicular. And then we're not going to do most of these questions. It's just straight up. It is straight up just the formula. We'll briefly talk about question 8. We're not going to do it because you'll see why. It says, which of these points is closest to the point A? We have 3 different points, B, C, D. We need to find which one of them is the closest to point A. What do we do? You find the what? The midpoint or what? You'll find the distance, yeah? You'll find the 3 distances. And that's it. You just use the distance formula 3 times. Cool?
Mm-hmm.
And it's just a calculator plug-in there, literally. You find AB, you find AC, you find AD, and then whichever one is the smallest number, that'll be the answer. All of these are just straight up distance formulas. We will do this question. So an amusement park is going to be built. Have you been? What amusement parks do you have in your city?
I don't really think we have any in Edmonton.
Have you been to any back when you were in Winnipeg or?
Wonderland in Toronto.
Nice, that's fun, yeah?
Mm-hmm.
All right, so what are we trying to do? We're trying to find the distance from a park to two different highways. All right, so P34, 3, 1, 2, 3, 4. So right there we have our point P. And highway 2 is represented by 2x plus 5. So we're gonna start at 5, go up 2 units, go across 1. So this green line is going to be highway 2. Something like that. So the equation on this line is 2x plus 5, and highway 10 is represented by negative 0.5x plus 2. So we start at 2, and for every 1 unit we go down, we go 2 units across. Something like that. And the blue one is y equals negative 0.5x plus 2. All right. What's the question? Determine the coordinates of the exits that must be built on each highway that results in the shortest road to the park. Okay, cool. So what are we actually trying to find in this question? So we're trying to find some coordinate here. I don't know where it's going to be, but we're trying to find some coordinate here. If it's the shortest distance, what's going to be the angle?
90 degrees.
90. So we need to find this point here. And similarly, we need to find this point here. And that will be the shortest distance. We don't have to find the distance itself, but we do need to find where the point is. So we don't really need most of these. All right, let's focus on this. I'm gonna call that point A. I'm gonna call this point B. We know the equation of this line is 2x plus 5. What's gonna be the slope of this line that's perpendicular to it?
Negative 1 over 2.
So MAB is negative 1 over 2. So this line AP. So that line AP is going to be y equals negative 1 over 2x plus b. What point can we plug in to find the y-intercept of the line AP?
3, 4.
3, 4. So 4 is equals to negative 1 over 2 times 3 plus b. So b will be 4 plus 3 over 2. That is 11 over 2, or 5.5. So plus 11 over 2. So we know the equation of this line as well. How do we find that point? So this line is negative 1 over 2x plus 11 over 2. We need to find
You
where...
set the two equations equal to each other to
Right,
find
that's
the
it.
coordinate.
So negative 1 over 2x plus 11 over 2, that's going to be 2x plus 5. So this will be 2.5x is equals to 0.5x. X is 1/5, so 0.2. That is our x value. And to find a y value, you just plug it into anything. I'm going to plug it here. It'll be 0.4 plus 5, it'll be 5.4. So that is the coordinate for that one. And for the other one, it's the same thing, right? What will be what's the negative reciprocal of negative 0.5?
It's 2.
Yeah, it's 2. So this line, BP will have the form 2x plus b. To find the b, the only point you can plug in is 3, 4. So it'll be 4 equals 2 times 3 plus b. B is going to be 1. So that equation is 2x plus 1. And then finally to find the point of intersection, you're gonna set 2x plus 1 is equals to negative 0.5x plus 2. So this 2.5x equals 1. So x is whatever that is, 0.4. Yeah. And then you can plug that in to get the y value and you're done. Okay?
Mhm.
Not that difficult. All these are just distance formulas. We don't have to get too much into it. As long as you have a calculator and you know it's x2 minus x1 squared plus y2 minus y1, you are good. I'm gonna skip that. Let's start with this. So remember, we're now doing circles. We're moving away from lines. The equation of a circle, the general form is this. It's going to be x squared plus y squared is gonna be equals to r squared. This is the general form of a circle. That has a origin at, that has a center of a circle at the origin at 0, 0. If it doesn't have its center at 0, 0, then it's gonna take this form, where the center now is hk instead of being 0, 0. So this is the equation that we're given. Where's the center of this circle? It's going to be at the origin because you're not subtracting anything from x, yeah? If it was x minus something, y minus something, then that is where the center would be. But in this case, it's going through the origin. What's the radius for this equation? X squared plus y squared is 25. What's going to be the radius of the circle? Remember, it's r squared on the right side. So if r squared is 25, what's r?
It's 5.
It's 5. So here in this example, we have a circle with its origin at the center and its radius is 5 units. So something like this. So this will be 5, this will be negative 5, this will be 5, this will be negative 5, and that's it. Cool?
Mm-hmm.
What's the diameter of the circle?
It's 10.
Yeah. So here we have a circle that has an origin. I'm just going to use straight lines. That has an origin at the center, and it says the circle passes through the point 8 and negative 6. So 8 and negative 6, let's say it's somewhere here. 8 and negative 6. So the circle is going to pass through this point. Determine the equation of the circle. If it goes through the center, it's going to be in this form. X squared plus y squared is equals to r squared. So if we have r, we have the answer to part A. So I'm going to connect this line from the center to this point. This is the radius.
Mm-hmm.
How do we find the distance of this radius? Remember the distance formula? You can just turn this into a triangle. The base of this triangle is 8 units on the x. What's the height of this triangle? The point
Negative
is, yeah,
6.
it's just 6. So what's going to be the hypotenuse? This is a Pythagorean triple. It's going to be a nice whole number. 10. 64 plus 36. So therefore, the equation of this circle is just simply x squared plus y squared equals 100.
Mm-hmm.
Now think about this for part B. We have a circle that has a radius of 10. So it's gonna go through here. Let's say this is 10. Let's say this is 10, and let's say this is -10. So our circle is gonna look something like this. It's not the best sketch, but like that. The question is asking us, if this is one of our endpoints, what is it going to be on this side? That's what the question is asking us. Use the idea of symmetry. If you take this point that's in quadrant 4, you shift it into quadrant 2, the numbers will be the exact same. The only difference will be the signs. What is this coordinate?
-8 and 6.
Yeah, -8 and 6. What about in quadrant 3?
-8 and -6.
Yeah, and in quadrant 1, cast rule, everything is going to be positive. So yeah, for part B, they just wanted this as the answer, but you could have also gotten these points. It's honestly pretty simple. This question looks tricky to say the least. Should we attempt this? So let's just, I mean, these are going to be the trickiest questions. So the diameter of this vegetable garden is 24. And all the paths, I think these guys, are 1.5 meters long. So how many circles do we have here? So 1.5, 1.5, like that. And the center of the circle is 6. It says 6 meters diameter, the flower bed in the center. All right. So this is 6. Now the question is, determine the equation of all the circles he's going to have to draw. All right. Let's start one by one. Let's start from the central circle. This thing, the diameter is 6, and we know it goes through the center of the circle. This is the origin point, 0, 0. What would be the equation of this circle? If the diameter is 6, what's the radius?
3.
3. So this one, it'll be x squared plus y squared equals 3. Is that correct?
Mm-hmm.
No, it should be 9. 3 squared. Remember, it's always r squared. So that's the innermost circle. Let's focus on this circle now. So this is 6, and we're told that this is 1.5. So what's the radius of this circle from here to here? So that's
7.5.
So this was 3, right? This was 3.
Oh, so it's 4.5.
That's 4.5. So the equation for that one will be x squared plus y squared equals 4.5 squared, whatever that is. And now I'm looking at this one. So we did the first two, now I'm looking at this one. Again, if you notice the pattern, it's just going to be 3 meters longer, because that was 6, that means half of this is going to be 3. So the third one will be x squared plus y squared equals 7.5 squared. The fourth one is just going to be 1.5 more on the radius. So it'll be 9 squared. And the last one is going to be 3 more. So it's going to be x squared plus y squared equals 12 squared. So those are the 5 circles and their equations. It just goes up by either 1.5 or by 3. And that's it. Let's look at this one. Now this one says there's a circle and it has endpoints at -8 and 15 and at 8 and -15. And it's the question now is what is the equation of this circle? All right. We're gonna assume it's going through the origin. So how do we find the radius?
You need to find the distance.
Yeah. So let's just focus from here to here. Or we could have done it on the other side as well. The base of this triangle is 8 units. The height of this triangle is 15 units. What's the hypotenuse of this triangle? I think it's 17. 64 plus 225.
289. The square root of that.
Yes, that's 17. We already have the answer. So what's the equation of this circle? We know that the radius is 17, right? And that's it. Equals 289 or equals 17 squared and you're done. Cool?
Mm-hmm.
That's it. Nothing too fancy. All right. Point A5 and 9B are on the circle. Determine the possible values of A and B. So let's start with A, 5. We know this is the equation of a circle. We're given a coordinate, right?
Mm-hmm.
The x value is missing. So let's just straight up plug this in. That's all you have to do. So here A is x, so this becomes a squared, plus y is 5, this becomes 5 squared, equals 125. So a squared becomes 100. So what's a?
It's 10.
Is it only 10? Can it be any other number except 10?
It can be -10.
Yeah, so it can be either positive or -10. Same thing with 9 comma b, we just plug it in. So this becomes 9 squared plus b squared equals 125. So b squared becomes 125 minus 81, which is 44. So what is b? If b squared is 44, what's b? It's just gonna be the square root.
Mm-hmm.
Plus minus though, because it can be both positive and negative. Cool.
Mm-hmm.
That's it. Circles, pretty straightforward. And we'll just do this. What's the radius in part A?
It's 4.
It is not 4. It is 4 over something. It's gonna be a fraction, it's not a whole number. Because it always has to be in the form of x squared plus y squared equals something. So in part A, what you need to do is you need to pull out the 9 first in the step 1, like this. So you get x squared plus y squared equals 16 over 9. So what's the radius? Four over 3, right?
Mhm.
What about B? What's the radius of B? So for B, the radius is 3. But the center is not at the origin. Where's the center? For A, the center was at 0, 0, because you're not subtracting anything from x nor y. But here the center is going to be, this is the general form, x minus h squared plus y minus k squared. Compare this with this. What's our h value?
2.
2. What about our k value? Negative 4.
It's 4.
It's negative 4.
Mhm.
Because negative k is positive 4, k will be negative 4. So in part B, now our circle is actually at 2 and negative 4. This is our circle, and it has a radius of 3 in all directions. So it'll probably look something like this. Whereas this one has a radius at the center, and its radius is at 1.33, so it'll look something like this. See if that made sense. The circle doesn't always have to be in the middle. Cool? Eventually what you'll see is you're gonna see something weird like this. Is there any way to make these two coefficients the same? And the answer is no. You can multiply it by 3 over 4 or 4 over 3 or whatever, but there's no way those two coefficients will ever be the same, yeah?
Mhm.
For a circle, those two coefficients have to be 1. Or at least they have to be the same, so you can throw it on the other side and make them 1. But here, you can't write it in that form, so this is not a circle, okay? So
Okay.
probably be like an ellipse or something like that. For a circle, it has to be 1 and 1 on both sides. Or it could be like a hyperbola or something. Let me double check what this would look like. Is this a circle? What do you think?
No.
No, why not? How do you know it's not a circle? Because the radiuses are different, right? The radii.
Mhm.
For a circle, the radius always has to be the same. Here, the radius is different. So this is like an ellipse, like an egg, like the Earth, where one point is shorter than the other. So for a circle, those coefficients always must be exactly the same. Let's look at this. It says a line segment has endpoints, these two. The question A is that verify that the endpoints of AB are on the circle. So how can we prove that those 2 points are part of this equation? You just plug them in, yeah?
Mhm.
Just plug them in as x and y, and if it works out, then you're good. So let's plug 6 and 7 in. So we get 6 squared plus 7 squared. That's 36 plus 49. That's 85. So point A is on the circle. For the next one, we have 2 squared plus 9 squared. That's 4 plus 81. That is also 85. So yes, that is also a point on that circle. You just plug it in. Part B, determine the equation of the perpendicular bisector of AB. Oof. All right, so 6 and -7. Let's say this is point A. And then B2, 9. Let's say this is B. Question's asking us to find the perpendicular bisector of this line. Do you remember what a perpendicular bisector is?
It's like a line through the middle.
Yeah? And can it be like anywhere in the middle, or does it have to
No,
be?
it has to have like an angle of 90 degrees.
Yeah, it's gonna have an angle of this thing. So we're trying to find the equation of this line. So how do we proceed? First, let's find the midpoint.
Mm-hmm.
So what's the midpoint between 2 and 6? 2. You just add them, divide them by 2. Add
It's
them,
4.
divide them by 2. So it's gonna be 4 and 1, okay? So now we have a point for our perpendicular bisector. Next, we're gonna have to find its slope. How do we find the slope of the perpendicular bisector? We first find the slope of the points that we have, and then we flip it.
Mm-hmm.
So let's find a slope from A to B. So the rise is how many units?
16.
16. What about the run? 4, right?
Mm-hmm.
And is the slope positive or negative for AB?
Negative.
Negative. So that gives us -4. So what's going to be the slope of our perpendicular bisector?
1/4.
Yeah, 1/4. Do we have any points we can plug in to find the y-intercept?
The midpoint we figured out.
Yeah, the midpoint. So we're going to plug this. Y becomes a 1. X becomes a 4. So this is always nice. It's a 0. So that line there is y equals 1/4x. And again, this is not to scale. That's why I didn't go through the origin here. So that is 1/4x. Explain how you can tell from its equation that the perpendicular bisector goes through the center of the circle. So the question is, how do we know this equation goes through the center of the circle? Where is the center of the circle? It's at the origin, yeah?
Mm-hmm.
So does 1/4x go through the origin?
Yes.
Yes, how do you know? Well, because the y-intercept is 0, right? If there's no b value,
Mm-hmm.
if there is no b value, then the y-intercept would be 0. That's it. So that's how we know it goes through the origin, and that's it for this question as well. All right, here, next we're gonna do something called classifying quadrilaterals. So let's say they give you this. Actually, these are your options. Let me show you what options you have. Actually, it also applies to triangles. So let's say they give you a figure, or they give you 4 coordinates, and they ask you to classify this quadrilateral. which one, like what's gonna be our procedure? So obviously these are not triangles, right? Because there's four sides. How can we eliminate each one of these options? Let's say, what do you notice from this diagram about their side lengths? Well, first of all, it looks like this side is equal to this side and this side is equal to this side, right?
Mhm.
Just appears to be. So it already kind of kills this, 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 and this. Because the opposite sides are equal. So that leaves us with four options. Well, we know we can show that these slopes are not perpendicular to one another. Because that doesn't appear to be 90. So if we find the slope from RS, we can show that this is not the negative reciprocal of the slope of QR. Because that angle doesn't appear to be 90.
So
So
it's not a rectangle or a square.
no, it's not a rectangle or a square. Now look at the difference between a parallelogram and a rhombus. What's the difference? It has something to do with the side lengths.
For a parallelogram, they're not all the same.
Exactly, and for rhombus they are, right?
Mhm.
So if we can show that this side length is different from this side length, it's a parallelogram. Otherwise, it's a rhombus. I'm gonna cheat. Where did it go? I want to see what the coordinates they get. PQQR. Again, they're just using the distance formula. So it turns out all the side lengths are 29.15. So all the side lengths are actually exactly the same. So what is this quadrilateral?
A rhombus.
A rhombus, yes. So it's basically through the power of elimination that we can kind of figure this out. Let's look at this triangle. It's asking us to classify this triangle. So again, we could have found this. I'm just kind of doing it just for time purposes. So let's look at this. They found the slope of AB and they found the slope of BC. And they got this number and this number. What does that mean about their slopes? It's the negative reciprocal, yeah?
So it's perpendicular.
It's perpendicular. And it also turns out that AB is equals to BC. So how would you classify this triangle?
A right angled triangle.
A right angle isosceles triangle.
Mhm.
What if I asked you, what is this angle?
They're both 45.
Yeah. Let's do another one, and we're also going to cheat for this one. It already says what type it is. Let me just see. Okay, that's whatever. All right, let's just call it there. We'll pick it up. We'll do like a full problem next time we meet.
Okay, thank you.
All right, see ya.